Okay, for erosion. As the river flows, pieces of rock are removed from the riverbed and banks and move along the channel. This removal and movement of rocks downstream by the river is known as erosion. Erosion causes the river channel to deepen and widen. Vertical erosion occurs when rocks and other materials from the riverbed are removed, causing the channel to become deeper. Lateral erosion occurs when rocks and other materials along the sides of the river channel are worn away. This causes the river channel to become wider. There are 4 types of processes involved in erosion. They are hydraulic action, corrosion, attrition, and solution. While each of these processes is different, it's important to know that they occur. Okay, for hydraulic action. The force of running water is the main cause of hydraulic action. In some rivers, the force or energy of fast-moving water is strong enough to loosen the rocks and soil along the riverbed and banks. Over time, the rocks and soil are dislodged and carried along the river. The river channel is eroded as a result. Okay, now for corrosion or abrasion. Corrosion, also known as abrasion, occurs when rock fragments are dragged along the riverbed or against the river banks. This grinding action causes the river channel to widen and deepen as rocks and soil are scraped off the sides and bottom and carried away with the water. Corrosion is particularly effective during a flood when the river's energy is at its maximum. Now for attrition. The river carries a load of eroded materials which contain rock fragments and other materials. These materials constantly collide with each other as they move. Over time, the collision causes the materials to break down into smaller pieces. Through this process, larger rocks are slowly broken down and their rough edges are smoothed out. This process of erosion, whereby the rocks in the sediment load are eroded by colliding with each other as they are carried along the river, is known as attrition. Okay, for solution. As rain falls to the Earth's surface, it reacts with the carbon dioxide present in the atmosphere, forming a weak acid known as carbonic acid. As this rainwater falls into rivers, the weak acid dissolves minerals present in the rocks on the riverbed and banks. For example, when a river flows over limestone, a chemical reaction occurs between the carbonic acid in the water and the calcium carbonate in the limestone. This chemical reaction, which is called carbonation, dissolves the calcium carbonate to form calcium bicarbonate. Solution occurs because calcium bicarbonate is soluble in water.
Larger sized materials such as boulders, pebbles, and gravel are found on the riverbed. These large materials are moved downstream by the process of traction, where they roll or slide along the riverbed. Saltation is the movement of materials downstream in a series of bouncing motions. Smaller materials, such as coarse sand particles, may be moved along the river's course in this manner as they get lifted up and dropped onto the riverbed over and over again. Finer particles such as silt, clay, and sand are carried along the river without touching the riverbed. These materials, which are held in suspension, usually form the greatest proportion of a river's load. They are also responsible for giving the river a murky appearance. Erosion takes place when minerals found in rocks, such as calcium carbonate, dissolve in the river water. The running water will continue to transport these dissolved materials downstream. This process is known as solution. Deposition occurs when a river does not have enough energy to either erode or transport material. It then puts down or deposits the load it is carrying. This usually occurs when the speed of the river is reduced. For example, during a period of low rainfall, the volume of water in the river drops, and so does the speed of the river. Thus, materials that are eroded in the river channel get deposited. Deposition can occur along the lower, middle, and upper courses of the river. Generally, larger particles, such as rocks and boulders, are deposited first, followed by gravel, then sand and silt. There are 5 factors that may cause deposition to occur. Number 1. During a period of lower precipitation. Number 2. When the river enters a lake or sea, resulting in a decrease in its speed. Number 3. When the river flows along the shallower side of a river channel, there is increased friction with the riverbank that causes the river to slow down. Number 4. When the river receives a sudden increase in load, or when incidents such as landslides occur. Number 5. When the river channel is obstructed by aquatic plants or protruding bedrock.
Waterfalls are sudden steep vertical flows of fast-flowing water falling from great heights. A waterfall is usually found in the upper course of a river where the gradient is steep. Waterfalls are normally formed in two ways. They may be formed through the erosion of rocks of different resistance or through faulting. An example of a waterfall formed in this way is the Niagara Falls, which stretches across the international boundary between the United States of America and Canada. A waterfall may also be formed through faulting. Faulting involves the movement of rocks along large cracks in the earth crust. This movement may result in the lifting of one block of land above the other. When the river flows down from the edge of the uplifted block, a waterfall and a plunge pool are formed. The river flows through an area with resistant rocks by its sides. It can only erode its channel vertically. Over time, a deep, narrow and steep-sided valley known as a gorge is formed. Gorges are more commonly found in the upper course of a river. The Catherine Gorge in Australia is one such example. Okay, now for valley. Erosion by rivers also creates landforms called valleys. A valley is a low area between hills or mountains. Valleys have different shapes. The shape of a valley depends on how the river erodes the land over which it flows. In the upper course of a river, the gradient of the land is very steep. Thus, the river has sufficient energy to erode the rocks in its path and cut deep into the channel, causing vertical erosion to occur. As a result, V-shaped, narrow and steep-sided valleys are formed. In the middle course of a river, the gradient of the land is not as steep as in the upper course. Therefore, the river flows with less energy and cuts less deeply into its channel. Lateral erosion occurs more than vertical erosion. As a result, the sides of the valley in the middle course tend to be wider than in the upper course. In the lower course of a river, the valleys are exceptionally wide compared to the upper and middle courses because the gradient of the land is gentle. As a result, lateral erosion rather than vertical erosion occurs. This gives rise to a broad, flat, flawed valley. Now we move on to floodplains and levees. When there is heavy rain, a river may overflow its banks. This causes the land on either side of the river to be flooded. As the floodwater from the river spreads out over a larger area, the water loses speed. When the water recedes, the river deposits the material it's carrying on the land, leaving behind alluvium on the river banks and river beds. The coarse sediments are deposited closer to the river's edge because they weigh more. The fine particles are deposited further away from the river. The deposited material, or alluvium, builds up on both sides of the river as more and more floods occur. Over time, wide and flat plains called floodplains are formed on either side of the river. The heavier and coarser materials nearer to the river form raised banks called levees. Floodplains and levees are depositional features which can be found at the lower course of a river. Now for meanders. Meanders are formed by a combination of the processes of erosion, transportation, and deposition along the river. Meanders are curves or bends along the river, which are usually found in the middle or lower course of a river, or where the floor of a valley is broad and the gradient is gentle. At a meander, erosion occurs on the outer bank of a river, and the eroded sediments are transported to the inner bank where they are deposited. Here, the water in the channel moves in a spiral fashion. The speed of the river also differs along its outer and inner banks. Along the outer bank, the speed of the river is high because there is less friction at the outer bank. Thus, the river has more energy and erosion can occur. Over time, the outer bank of the river gets undercut and a steep-sided bank, known as a river cliff, is formed. The sediments removed from the outer bank are carried by the flow of the water and deposited along the inner bank. Deposition occurs at the inner bank because the friction between the inner bank and the water is greater than at the outer bank. This reduces the speed and causes the river to drop its load. Over time, as more sediments are deposited, the water becomes shallower at the inner bank and the river channel becomes asymmetrical. A gentle slope formed by the deposition of sediments along the inner bank, known as a slip-off slope, is formed. This process is repeated as the river moves downstream. Okay, for Oxbow lakes. Meanders can become so distinct that they develop into another feature known as an Oxbow lake. With constant erosion along the outer banks of two consecutive meanders, the two meanders move closer to each other, forming a loop. Over time, the loop becomes more distinct and is separated by a narrow neck of land. This neck gets narrower with continual erosion and deposition. As deposition and erosion continues to take place along the inner and outer banks respectively, the two meanders eventually meet. The sediments deposited will eventually dam out the water and cut off, forming an Oxbow lake. The river will now flow in a straight path for a short distance before it begins to meander again. Oxbow lakes are generally temporary features. As it is cut off from the main river, the Oxbow lakes will eventually dry up due to evaporation and encourage the growth of vegetation. But not last, deltas and distributaries. As the river approaches a sea or lake, its speed decreases, thus it deposits its sediments at the river mouth. Some of the deposited sediments may be removed by tides and currents. However, if the rate of deposition is faster than the removal of these sediments, the sediments will accumulate and build up at the river mouth. This results in the formation of a delta, which is an accumulation of alluvium and sediments at the mouth of a river, where it enters a sea or lake. Over time, as more alluvium is deposited, the delta extends outwards to the sea. When this happens, the river channel branches out to form many smaller channels known as distributaries.